Hi everyone, today we'll be doing logarithms. So first, let's start off with the basics. So say I have an exponent in the form b to the power x is equal to a. So say it's 2 to the power 3 is equal to 8. Now I've been told that I need to write this in logarithm form. How do I do that? This can be written in the form log base b a is equal to x. What this essentially means is that b to the power of x will give me the answer a. So it forms a full circle in anti-clockwise direction. Now this is particularly useful when you don't know. So say if I have 2 to the power x is equal to 16 and I don't know the value of x. What do? I can simply write this in logarithm form. So I can write this as log 2 is our base, so log 2. Answer is 16 is equal to x, what we are finding. From here I can put this straight into my calculator and get that x is equal to 4. Now this was much easier for smaller numbers, but when you have larger numbers which can go in standard form, that's when logs can come in handy. So let's take a few examples. So say I have 5 to the power 3 is equal to 125 and I have to write this in logarithm form. What will I do? My base remains my base, so log 5. My answer comes here is equal to 3, so we form full circle again. So 5 to the power 3 will give me 125. Now let's move on to the rules of logarithms. So let's go with the first rule. If I have any two logs, so log bm plus log bn, both with the same base, they can be written in the form log b m into n. So m and n get multiplied here. So this is our first rule, also called the product rule. Now how does this work? Now say I have a log, so log 39 plus log 327. What are my values for each of these? We know 3 to the power 2, which would come somewhere here, will give me 9. So the value of this is equal to 2. 3 to the power 3 will give me 27. So the value of this is 3 is equal to log 3 m into n. So 9 into 27, which is 243. I know that 3 to the power 5 is equal to 243. So the value of log 3 243 is equal to what? 5. So this rule is correct. Now the only thing that you have to take care of here is that the base must always be the same. This cannot be true if you have log 39 plus log 2 16. This would be wrong and would not work in such a scenario. Okay, so now let's move on to our third case, which is if I have two logarithms which are being subtracted. So log bm minus log bn, again with the same base, they can be written in the form log b m divided by n. Now let's understand this with an example again. If I have, say, log 5 125 minus log 5 25, what will I have to do here? What am I going to do here? I can just simply write this as log 5 125, which is my m, upon 25. So 125 by 25. What is log 5 125? We know 5 to the power 3 will give me 125. So the value of log 5 125 is equal to 3. Log 5 25 is equal to 2, because 5 to the power 2 is equal to 25. minus 2 is equal to log⁵ 5. And log⁵ 5 is equal to 1 because 5 to the power 1 will always be 1. So this rule is also correct. This rule is called the division rule. Again, you have to take care of the same thing. The base must always be the same. Now the second thing here is that the log with the positive sign in front will always go at the top. This means that this cannot be written in the form log p n by m. This would be wrong. So the one with the positive sign would be the one on the top, which means it'll always be the numerator, and the one with the negative sign will always be the denominator. Okay, now let's quickly move on to our fourth rule, which is that if I had a logarithm which is log p m to the power n, this can be written as n log b m. Now let's see how. Okay, if I say that I want to write 2 to the power n, what does this mean? It means 2 into 2 into 2, which goes n times, right? Because what is 2? What is 2 to the power 3? It's 2 into 2 into 2, 3 times. So 2 to the power n would be 2 into 2 into 2 for n times. Similarly, m to the power n is what? M into m goes on till n times. We know that from our first rule, which was our product rule, we know that log b m into n is equal to log b m plus log b n, correct? Now similarly, this product rule will also be applicable for n number of terms getting multiplied here. So if this was m into n into p into q, they will all get added up in logarithm form. Similarly, log b m to the power n can be written as log b m into m into m into m for n times. Using my product rule, we know that when all of these terms are getting multiplied with each other, they can also be added up separately. So this can be written as log bm plus log bm plus log bm, goes on till n terms. So this can then be written as n times log bm because it's going on till n terms, right? If I had 2 plus 2 plus 2 plus 2 for n terms, we can write this as 2n, correct? Using the same logic, we get this rule. Using the same logic, we get this rule. So you may note it again. If I have a logarithm which is log b m to the power n, it can be written as n log bm. So the power comes in front of the logarithm and gets multiplied with the entire log. Now for this part of the video, let's quickly go over two things. In an exam, if you ever face this, log b1, this is always 0. This is a no-brainer. You do not have to think about this. Now that's one. The second one is, if I have a logarithm which is log a, the value of this will always be 1, no matter what. But if this was written in the form log a to the power 5, what would the answer of this be? This would be 5, because 5 would come in front of the power as discussed here. Now a lot of students do this, that they take log a as 1, so this thing as 1 to the power 5 is equal to 1, which is completely wrong, because you have to note here that the power here of 5 is not raised to the entire logarithm, but it's only to a. if the question states that the power of 5 is for the entire logarithm, then that method might be correct. But for here, the answer will be A. So for log a to the power m, answer is m. So that was it for this episode of Logarithms. Stay tuned for the next part where we discuss more tips and tricks.